Hi, welcome everyone. Thank you for joining us this afternoon. Excited to have you all here for this latest on the 1T.org US Community Collaborative webinar series. This one's putting a science spotlight, which we like to do periodically, featuring and highlighting some of the latest and greatest data and science that is out there and of interest to the forest community. Today, we're really fortunate to have Dr. Susan Cook-Patton, who's a lead reforestation scientist at the Nature Conservancy, and her colleague Kurt Fesenmyer, who's a data and GIS spatial analysis for TNC, on hand to talk a little bit about their brand new paper addressing critiques, refines global estimates of reforestation potential for climate change mitigation. Exciting title and exciting work being done on refining some of the great data sets that are out there about reforestation potential globally and in specific countries around the world. So thanks so much for joining us, and I'm excited to turn it over now to Dr. Susan Cook-Patton. Thanks for being with us again, Susan, and making the time to join us today.
Great, thank you. And Kurt, do you want to start screen sharing? Well, thank you for the invitation to speak with you all. We're excited to share some of our new work, but this was also an endeavor that we approached with humility and trepidation because there's global maps of reforestation opportunity are a contentious topic. So would be excited just to hear your thoughts and feedback on what we've done as well. But yes, as Kevin said, I'm a lead reforestation scientist at the Nature Conservancy and worked very closely with Kurt Fesenmyer, who's our forest spatial data scientist and data wizard, and is the one who really put this all together. But just to take a step back, if you want to switch to the next slide, I'm sure it is no surprise to the folks in this audience that reforestation is a really prominent climate solution. The original attempt to quantify all the different ways we could work with nature to tackle climate change, led by Bronson Griscom back in 2017, found that reforestation was the biggest opportunity. But why we have a little star next to largest, the error bars around that estimate were so big, they literally fell off the figure. That's what that little star is at the end, because it sort of shoots off the end. And I often say that I got my job because of this error bar. I am responsible for trying to improve our understanding of how we can leverage what I call putting trees back into the ground as a climate solution. And some of the prominent sources of uncertainty are first, how much carbon can be accumulated? And how does that differ depending on what you're doing, like natural regrowth, plantations, agroforestry, and where are you doing it? Because trees grow very differently in different parts of the globe. Another prominent source of uncertainty is albedo, which I'll get to more. And then the big one that we're mostly here to talk about today is what locations are actually reforestable. So for that, I'll turn over to Kurt. But first, how much carbon can be accumulated? This was some of our first work where initial estimates of the mitigation potential of reforestation would use like a carbon accumulation rate number for a large area, like temperate forest within the US would all get one number. But we know that there's a lot of variation depending on things like topography and soil type and species, and that just is not captured in a single number. So this first work, this is from 2020, we actually mapped potential carbon accumulation for natural forest regeneration across the globe, and you get a different rate for every square kilometer on Earth. And what we find is over 100-fold variation in carbon accumulation potential, depending on where you are. And when you look at this, you're like, okay, yeah, tropics get faster carbon, like more northern and slower carbon. But actually, if you zoom in, you do see quite a lot of variation at fairly fine spatial scales. And this map is useful because it helps to identify the places where you can get the greatest carbon return per hectare of investment to help prioritize investment in places that are most likely to yield the biggest benefits. And just to mention very briefly, another paper that we had, you could flip, come out 3 days ago now. So that one was a great paper that showed how carbon varied through space, but carbon accumulation also varies through time. Like your standard forest growth curve is forests start growing slow, and then they really pick up, and then they slow down again. And so if we're trying to say like, how much carbon can we get by 2030? How much carbon can we get by 2050? These big policy windows. We really need to understand how old is the forest when it starts and like how much time do you have to get to those different rates. So now we've got, very excited about this, new data sets where for every relevant kilometer squared on Earth, we can tell you what the maximum carbon removal rate is, when that maximum removal rate occurs, and how it changes through time. So if you want to know the difference in carbon removal between a 5-year-old forest and a 12-year-old forest here versus there, we finally have the data that allows you to do that. So it's very exciting. Next slide, Kurt. The other sort of big uncertainty element that we tried to tackle was albedo. And albedo is basically how much sunlight is, energy from the sun is retained within the Earth system versus reflected back out into space. And often when you're thinking about reforestation, grasslands or bare soil, snow-covered landscapes, sandy soils can be quite reflective. And then if you put trees in there, they're darker, and imagine wearing a dark shirt on a sunny day, like you can feel that heat sort of retained within the system. And on a global scale, what this means is that as you add trees back, often the earth gets less reflective, it gets darker, and that can reduce some of the cooling that comes from carbon removal alone. And so what you get is that sort of dotted net CO2 effect that is somewhere in the middle. And in some cases, if you want to flip to the next slide, Kurt, can actually entirely negate the climate benefit of carbon storage. And it used to be that people would just sort of draw a line at the boreal and say, like, there be albedo dragons up there, like, don't do reforestation. But we found that it's much more spatially patterned and diverse than that. Like, you can look in the boreal, there are places that are net climate positive from reforestation, places that aren't. And there are places within the US, in the sort of rocky areas, where reforestation may not lead to a net climate benefit. And so we use these maps to help target the places where reforestation is most likely to act as a powerful climate solution. So those were two major sources of uncertainty, but the next one is the big one, which is where are we going to put all those trees? So there's many big goals to do a lot of reforestation around the globe, and figuring out where exactly we can put those trees is a big open question. So that's where our new paper comes in that Kurt led, called Addressing Critiques to Refine Global Estimates of Reforestation Potential for Climate Change Mitigation. And this paper had great coverage in The Guardian. We can share the link afterwards, and has already been accessed over 13,000 times in the 2.5 weeks, which is since it's been out, which is not, Taylor Swift level exciting, but pretty great for a pretty great for a science paper. So with that, I will turn it over to Kurt to tell you the ins and outs of this work.
Thanks, Susan. Yeah, so perfect stage setting from Susan, and I'm going to come back to a few of the data sets that she described. But to put this in context a little bit more, so part of the origin story for this analysis was the Nature Conservancy, working with partners, has put together a new tool called NatureBase. It's a web-based tool for identifying where, why, and how nature can help mitigate climate change. And one of the layers in that map tool is obviously where reforestation could occur, because it is the largest removal opportunity. And so of around 4 years ago, we started to look at the existing global maps and try to determine which of those is the best one that we can incorporate into NatureBase. And as part of that, what we want to do is just survey what maps are out there. And one of our really early conclusions was that there are many maps available for reforestation. This figure just shows globally at different administrative units what maps are available, but since 2011, just to give you a feel for the size of the number of maps, there have been 89 maps. 7 of those are global in scale, 10 are regional, and 72 are national or subnational. There are some places on the globe in particular. I know a lot of the audience here is probably from the US, but the US has a number of national or subnational analyses available. Brazil's another place with a lot of both interest in reforestation and available maps. So the good news is there are a lot of maps available. The challenging news is that there's a lot of potential maps to wade through. And so it does beg the question, do we really need another reforestation map? Does an updated map really something that we need? And we concluded that the answer was yes. And that was primarily because many of those existing maps, particularly those global maps, have been subject to a lot of critical commentary in the scientific literature and the popular press. So these are just a few of the titles of some of the publications that have come out criticizing existing global reforestation maps. So our objective was to build off of the existing maps and methods to try to take the best aspects of those existing products and address the key critiques. We also wanted to incorporate the latest high-resolution data sets because land use and land use change is a dynamic process. We wanted to use the best available or most recent spatial data. And we also wanted to demonstrate that the answer that you get for where reforestation opportunities exist is highly dependent on different values that you bring to that question. And so we didn't want to present a single answer. We wanted to present a suite of answers so that users could potentially evaluate how the answer changes when you have different objectives or goals. So as part of this process, we assembled an author team that includes experts across lots of different domains, including several of the authors of the existing, those previous critiques. So those include grassland and savanna scientists, social scientists, forest mapping scientists, and albedo scientists, as well as several of my colleagues from the Nature Conservancy. So in that review, back to that global map that I showed of the 89 existing maps, part of the process for the paper was just reviewing what were the methods that those papers used, and then are there insights we can bring to bear on a new global map? And we identified that those existing maps use a common recipe. It's typically 5 basic steps. First, you need to define forest, and that usually uses definitions related to tree cover, canopy cover, or biomass. Next, you need to map where forest could typically occur. So that's basically forest suitability. Next step would be to exclude areas where there are practical limitations to where forests could occur. Next, you apply some safeguards, for example, excluding croplands. And then finally, overlay some additional factors to contextualize the results, things like carbon sequestration. Now I'm going to walk through just several of those critiques that have been associated with each of these steps of the recipe. So the first set of critiques focus on definitions about what is a forest and where can it occur. Previously, a lot of the global reforestation maps have used a 10 or 25% tree cover to define forest, which tends to include savannas or woodlands where existing tree cover may be less than its potential due to disturbances like wildfire or herbivory. The result of these broad definitions is that reforestation opportunity tends to be mapped in places where there are not that disturbances are limiting tree cover rather than changes in land use, and where tree cover gains may not be permanent, or where increasing forest cover can have biodiversity, soil carbon, ecosystem service, or durability implications. The next set of critiques are data critiques, and they relate to how existing land cover is mapped. And this is I get to share with this audience my mappy nerdiness, but this is related to things like just the ability of existing forest maps of where forest cover is to actually detect existing tree cover. So this is just an aerial image of southern Idaho near where I live, showing a global forest cover product overlaid in green. So you can see that there are a lot of places where you have low tree cover or low tree density that are missed by these maps. So as a result of that issue, you're potentially showing reforestation opportunity in places where you already have trees. Another mapping critique relates to the use of mosaic land cover products that include mosaic classes. So this is just an example from Cuba, where you see that there is a class here, this peach pinky color, that's kind of a lump. It's a catch-all class, cropland with natural vegetation that includes up to 40 to 60% of natural tree cover or herbaceous vegetation. So again, including this land cover as an opportunity for reforestation misses the fact that there's already often natural vegetation in these places. And then the final set of critiques are precautionary critiques, and they relate to perverse outcomes that haven't been considered by those existing maps. Failure to consider food security and associated leakage is a very common critique, but there are others, and those relate to albedo, which Susan described, equity implications related to low incomes, land tenure issues, subsistence agriculture, or the ability to affect local land use policy, basically people not being considered at all in these mapping exercises. And the result is that reforestation is being mapped in places where there can be negative community or climate effects. So how did we modify the recipe to address those critiques? First, we used a very conservative tree cover threshold to explicitly exclude woodlands and savannas from what we considered a forest. So the maps that you'll see and the results that we described are really focused on closed canopy forests and exclude open canopy ecosystems. Next, we looked for, we used the two existing forest potential maps, the maps developed by Baston and others, and Walker and others. And we looked at areas where those potential forest maps agree. So we wanted to have high confidence where forests could potentially occur. And then we excluded places with frequent fires. So that was any place with 2 or more non-cropland fires in the last 20 years. These 2 steps alone reduced the potential forest area compared to previous global maps by anywhere from 65 to 75%. So this is our new potential forest map. You can see the area we map in green. The places that we excluded due to frequent fire are in orange. And then in dark gray is the maximum potential forest extent in 5 of the other global forest maps. So this is just where trees could occur, not necessarily where reforestation could occur. But you can see quite a broad extent for potential forest in those existing maps, and a much smaller area in the maps we present. So next, to address practical limitations, we used 30-meter global map products, which are focused on single land cover classes, so not mosaic data sets from the year 2020. And we accounted for overlap. We looked at existing forest, water, ice and snow, persistent bare ground, or rock. Next, for safeguards, we used similar 2020 era data for the land cover for croplands and wetlands. We also included a coarser resolution peatlands layer, an urban area layer, and the albedo layer that Susan described. So the result is this new constrained reforestation map. The color ramp here, this is just for the sake of interpretability, shown at the scale of 1, these are 1-degree cells with colored high reforestation opportunity as a percent of that cell in dark green, low opportunity as a percent of the cell in light green. So the area that we map is 195 million hectares globally. That's 71 to 92% smaller than existing global products. We have large areas of the new map that are excluded by areas in the other global maps. And the largest reason for difference with those other global maps relates to the potential forest mapping that I showed in the previous step. So our very conservative definition about what is a forest and where could a forest occur really constrained or limited the area that we show as reforestation opportunity. 8 to 21% of other opportunity maps overlap with areas with frequent fire is another important conclusion. So back to the map I showed, those areas that have 2 or more fires in the last 20 years, anywhere from 8 to 21% of the other global reforestation maps overlap with those areas. So then as a final step, we took that contextualized reforestation potential that I just showed, and we overlaid several other data sets that we thought provided important context. Those include things like climate mitigation, additionality, ecosystem services, again, people, an important piece, and government policies. I'm going to show several examples of those scenarios, which again are taking that 195 million hectares and then further refining them based on different criteria. So this is just dividing those different scenarios into different groups. I mentioned ecosystem services, but that includes a focus on water quality. So looking at areas with high slopes or in floodplains. Forest neighborhood, that's just looking at places with high tree cover within a 5-kilometer neighborhood. We looked at social conflict scenarios. Those include focusing on places with high individual rights or places where people are, through participatory processes, able to affect local land use and decisions. We looked at secure land tenure, or whether the rights to land are clearly established legally in individual countries. We looked at low rural livelihood context, which is just to say areas with higher poverty and people who are more likely to be dependent on nature for food, for fuel, and for their livelihoods. And then finally, we looked at 2 scenarios related to government policies. That's protected areas and national restoration goals. So I'm going to show a few results from the Reforestation Hub, the Global Reforestation Hub. I'll provide a link to that at the end of the presentation, but it's an interactive tool for exploring these results in the various scenarios. So you can use this selection box in the lower left to turn on the different scenarios. You can click on individual countries and see how the results vary at the country, state, or county scale equivalent. So this is total opportunity, and I've just selected Bolivia to highlight. Bolivia has 2.4 million hectares of opportunity for total opportunity or constrained reforestation potential. When we look at secure land tenure, though, Bolivia does not have secure land tenure, so that value goes to 0. And the same for individual rights. But you can see how there are also these other scenario results that we present. At the risk of overwhelming everyone with a few more numbers and a complex figure, I'll just share this figure that comes straight from the paper. And the main takeaway from this is that there are few win-wins, but very few win-win-wins or win-win-win-win-wins. So this is just showing the total area available for reforestation under different scenarios. This first column is the constrained reforestation potential that I showed in the map. And then these different symbols correspond to different combinations. So the forest neighborhood scenario has 161 million hectares, which is to say that there are lots of places where reforestation is an opportunity that are close to other existing forests. Those may have co-benefits for biodiversity or be places where natural regeneration is an option for reestablishment of forests. And then as we start to stack up these different combinations, it becomes much challenging to find area that kind of meet all of our different criteria. So just to pick another one, if we look at the 3 avoiding social conflict scenarios, high individual rights, secure land tenure, and low rural livelihood context, once you apply a lens to say where do all 3 of those factors co-occur, we've reduced the total area for reforestation to 90 million hectares, or almost by, or just less than half. Yeah. So to come back to a high-level conclusion, back to Susan's slide that she showed, reforestation still is the largest opportunity for removals. But it's reduced from previous estimates when we include these safeguards. So potential use cases for our analysis. I think it's important to keep in mind this is a global analysis, and we did highlight that there are lots of local analyses available. So what is the utility of a global analysis? Back to that map I showed for where local maps are available. It's still the case that 80% of the countries globally, there's no national or subnational map available. So this global map is going to be the best available starting place for evaluating reforestation opportunities. We think it's also important from a policy perspective to provide a right-sized estimate of the overall size and magnitude of reforestation opportunity and mobilize resources to those places with the greatest relative opportunity. For places without national, subnational, or regional analyses, we think that we've provided a nice framework that incorporates some of the critiques that have been leveled at other global maps that are still useful critiques to keep in mind when operating at the national, subnational, or local level. And we provide access to code and data so that others can modify and update this analysis to suit their local needs. So with that, I think we can turn to questions. I just want to acknowledge Bezos Earth Fund for funding for this project. Obviously, the research team that put the work together. I've provided here some additional resources, including links to the publication, the code and data, the Reforestation Hub that I mentioned, as well as NatureBase, which is available for exploring other natural climate solutions. And then also, I want to flag just for probably the US-centric audience here that there's also a US Reforestation Hub, which provides an opportunity to explore, similar to the Global Reforestation Hub, explore previous analyses of reforestation opportunity that specifically uses US data sources and adjust some of the questions, goals, and motivations to US contexts. And with that, I'll stop. Thanks.
Brilliant. Thanks, Kurt. Thanks, Susan. And as my colleague Audrey said, feel free to drop questions in the chat, and I'm happy to read those. But while folks are germinating on that, Kurt, in sort of our pre-call, we talked a little bit more about sort of other directions, other research topics and refinements that have come out of this paper. What are you excited about, and what are some of the other topics that you all are looking to dive in on as the research progresses?
Yeah, thanks, Kevin. I'll start with a few that we highlight in the paper, and then I'll turn to Susan and let her describe some ongoing research that our team and partners are working on. We know there are limitations to for example, the land cover data. Those critiques that have been leveled at land cover those are still persistent to a certain degree in the data sets that we use. There's always an opportunity for higher resolution, more timely data sets that map not just where trees are or individual trees are, but things like pasture. We think pasture represents a large opportunity for reforestation in our analysis, but we don't know if where livestock are on a landscape. So that may help refine whether or not an opportunity is reforestation or is something like silvopasture. Another highlight, I'll highlight just another data set that we know is limited is just the land tenure. It's such a critical piece for the people involved in reforestation, and there's really not great data available at a global scale for knowing just how well land rights are established. So developments in that realm, I think, will really advance this work. And then another piece I didn't go into much detail on, but it's related to those overlays that we present, is additionality. So we looked at the background rate of forest loss and forest gain. And we did what we think is a good job with the data we have available, but we know that teasing apart the sources of tree cover loss and a more refined perspective on the rates of tree cover loss could really help get at additionality or kind of where reforestation opportunities would be more than business as usual tree cover recovery. Susan, you want to add to that?
Well, I'll just say one of the things that I think is most useful about our work is not saying where reforestation should happen, but highlighting places on the map that merit additional focus and exploration. And of course, talking with the local communities to see if they even actually want trees there. And so some of the work I'm excited about is hoping that this just accelerates those conversations. And we've seen some of it already in feedback with like, oh, I didn't actually think about that opportunity in my landscape. And we'll start having conversations with our partners and exploring that in more detail. And that's exactly the sort of work that we wanted to come out of this. As far as advancing reforestation as a climate solution more broadly, the other area that have been working on with many partners for a while, and we just need to get it done and out the door, is around agroforestry as a climate solution. So there's lots of different ways that you can put trees back into the landscape. You can let the forest regrow on their own when the conditions are right. You can set up a plantation or an agroforestry system when livelihoods are paramount. And I think agroforestry actually has a lot of potential because much of our land is already being used by humans. And it's often a question of how can we just incorporate more trees into human land uses. And agroforestry is a potential win-win-win with carbon, biodiversity, and improved livelihoods. But the carbon numbers are just terrible. Like it is like total Wild West. So we've been doing a massive literature search through 25,000 publications, and we're doing the data scraping and compilation that we do. And so if anyone out there needs agroforestry carbon numbers, ask me because we have them compiled. We just need to get them finally cleaned and put all together. And then the other thing we're doing that has been, albedo was one of those like, oh, we've got to do albedo. And then durability is the next big thing that we're tackling. Because I think there's this perception that like all the forests are going to burn. And like that's not true, right? Like it varies across the landscape. Some places are more susceptible than others. And if we can get good durability risk maps, we can help prioritize action in the places that are more likely to be stable. And if we have a better understanding of how much carbon is actually likely to be lost from a disturbance, because it's not like everything disappears, some of it is left on the landscape, then we can help inform sort of compensation mechanisms, like what does the size of the buffer pool need to be? And lastly, the part that gets forgotten is that forests are disturbed, but they regrow, right? It's not like fossil fuel emissions, which is a one-time emission. Like forests are dynamic. So I think we just need a much more nuanced understanding of what durability risks look like across the landscape. And we are pushing on that on several fronts.
While you are on the topic of durability, Susan, you and Bronson Griscom from CI just published a piece in the World Economic Forum blog this week talking about durability, permanence, and natural climate solutions in the whole. Could you touch a little bit on some of the key takeaways on that? Because I thought that was a really powerful argument that you both made on the durability piece.
Oh yeah, thank you. And I'll say they have rules that only 2 authors can be up front, and Bronson and I did much of it, so we got to be the first 2. But there were 10 of us. You got to scroll to the bottom. It was actually a multi-organizational, many science sort of consensus that it took a lot of work to get us all to agree. So I definitely want to acknowledge that it was a consensus piece. I think the big thing, other than the recognizing that durability is a much more complex topic, some of the main take homes were, one, we really have to work with the solutions that are at hand. Like nature-based climate solutions are scalable and ready now. And even though there's some durability risks, those durability risks are not uniform, and we can work with that. And the alternative is technological solutions, engineered solutions, but they're frankly a very expensive small drop in the bucket of what we need. They're just not scalable. And nature-based solutions come with a bunch of other benefits like biodiversity and improved livelihood, and help to drive resources toward communities that are feeling the results of climate change and yet are often the least responsible for climate change in the first place. So it's sort of like it was a call to action of, please, let's not let the perfect be the enemy of the good, and let's use what we have now. Trees have evolved for millions of years to figure out how to pull carbon out of the atmosphere. The R&D is done. We just need to get the trees into the ground. So that was the main point, I think, that we wanted to make with that.
Here, and elegantly done. And thank you for noting that this was not just a 2-person project, but a lot more great science involved in this. From the chat, from Charlie, we're developing the Forest Innovation Platform at American Forest, and we'll be using some of your impressive layers. or if anyone knows of reliable projections of reforestation potential, more specifically using the MACA downscaled climate models. You may want to explain what that is, but feel free, both Susan and Kurt, to jump in.
So I'll start with that, Kurt. You should follow up. I'll say actually one limitation of our study is we don't attempt to account for future climate. This is based off of our forest potential maps are based off of historical forest extent. And so that actually is a frontier to try to predict where we think forests are going to be best suited under future climate conditions. That said, I think many of our deductions, like those sort of woodland, cutting out sort of the woodland ecosystems, as well as the albedo, which tends to remove drylands, are the places, those are the places that are most likely to transition to not forest suitable. And so it's an open question as to how big of a deal it is. I think we have sort of inadvertently dealt with it to some degree, but actually directly quantifying it, I think that's a frontier still. Kurt, do you want to add anything to that?
Yeah, I think that's right. I guess the other thing I would add, it's related to your durability point, is just we're looking at existing fire regimes when we think about fire-prone landscapes, and those landscapes may change with changing climate as well. So yeah, it's a space, it's an opportunity for improvement. I mean, there are a few existing products that do incorporate future climate. The Baston and others analysis from several years ago includes potential tree cover layer that is forecasting future climate. So you might want to look at that, and you could potentially modify it to suit your needs, or use our code and modify it to incorporate some of the conservative criteria we apply to it.
Thanks. Yeah, and we'll be sure to send the slides and the links out to folks who are interested in looking under the hood and seeing that code and digging in on this. Mary asked, how should we think about these new safeguards in the United States, and will the U.S. Reforestation Hub data be updated?
For the US Reforestation Hub, we are in the process of updating it. I've often wondered if it's annoying. I would love to hear from the folks. Like, is it annoying that the numbers keep changing? But I hope that you recognize this is in the spirit of really improving and refining and honing our understanding of the most promising location. But the current updates are to improve our estimates of carbon accumulation. So that new paper that just came out 3 years ago, that gives you like a carbon accumulation growth curve for every square kilometer. That's the one that we're putting in the Reforestation Hub, because before we were using Forest Service numbers that were just like one number for like a big general forest type. There's also new spatially explicit soil carbon numbers coming out in about a month, I think. And so we're putting those in, and we're also putting in albedo. As far as the social safeguards, or the just safeguards in general, so albedo is included. Crops we already exclude to avoid impinging on food security, except for croplands that have a severe constraint on production. So these are places where they're sort of more marginal. Those are still in. And then tenure and those other issues, like the US tends to score highly on those. So we don't have those explicitly incorporated into the Reforestation Hub. But yes, maybe 6 months, the US Reforestation Hub's numbers will be updated. And just to clarify, like, we've got this new great global map, but whenever there's a national map, that's we would say probably go with the national map. It's going to have much more refined estimates that can account for sort of finer scale variation, as well as just locally relevant criteria. So if you're in the US, go to the US Reforestation Hub. But if you're in the vast majority of countries that don't have a national data set on which to lean, then hopefully our new map can be useful.
Great news, and we'll look forward to having you back in 6 months with the rest of the team on the Reforestation Hub US specific data. Jennifer asks about albedo differences depending on conifers versus hardwoods. Maybe a quick summary of some of the research on the albedo that you've presented in the past.
You're right. Yes. So usually conifer stand is going to have a darker result than a deciduous tree because one, the needles are darker and they're there all year versus deciduous trees that drop them during the winter. And what we did in our albedo work to enable the creation of a map was to make an assumption about what the starting condition looked like. Was it grassland? Was it cropland? And that was just based off of what was most common in that area. And then the end condition, so whether it would be a deciduous forest type or a coniferous forest type at the end. And so we have sort of rough estimates, but we do actually have what we call single transition layers. So you can like say like, oh no, I'm turning a grassland to a deciduous forest. You can find a layer that will quantify the albedo change specifically for that. But it's a good question because you could make that decision. You're going to say like, okay, I could choose between establishing a coniferous forest and a deciduous forest, and albedo is a concern. So I'm going to go for the deciduous forest, and you would then wind up with a larger net climate benefit because you're choosing a forest cover type that's going to have less of an albedo offset or deduction. Oh, you're muted, Kevin.
Sorry, thanks. I was going to say we're happy to link to the albedo paper in the post webinar wrap up. Question from Thea. When it comes to afforestation, based on the data so far, how efficient do you see it as a solution for climate support and biodiversity in combating desertification?
I can start with that one. So our approach here was to focus on reforestation, not afforestation, and that's a subtle difference that can be used in different ways by different folks. But by focusing on reforestation, we're suggesting that's trees in places where trees historically occurred, distinct from afforestation, putting trees in places where trees may not have otherwise naturally grow. That's more common. Afforestation is more common in that afforestation afforestation is more common in that as a tool for combating desertification in places like northern China, northern Africa. So it's a strategy we largely excluded from our analysis because we were focused on reforestation, and then the conservatory rules we used for defining forest would have also excluded those landscapes.
And I'll just say, because I know we're talking to a primarily US audience, like afforestation is such an annoying term because it means different things in different places. But we were using it to mean putting trees where they would not naturally occur is afforestation. Reforestation is putting trees where they would naturally occur. And I think an important thing to remember is we are talking about reforestation as a climate solution, and there's lots of good reasons to do reforestation as other solutions. So preventing desertification is one of those things where it might not have a large climate benefit at the global level, but it could provide local cooling as well as preventing sort of the spread of deserts into places we don't want them to go. So we're not saying you shouldn't do reforestation in other places outside of the area identified in our map. We're just trying to focus on the places that make the most sense for climate and then contextualizing it with all those other pieces of information that Kurt described.
We got a similar thread. Sophie asked about in fire-prone regions that were removed from the data sets, recommendations and sort of guidance for how you're thinking about those places.
Yeah, it's a similar answer there too. So we're not at all suggesting that there are not savannas or fire-prone landscapes where a reforestation approach may make sense. Rather, that those are tricky questions about how best to approach that in those locations that are best answered with local perspectives and local information. So again, we wanted to be conservative for getting this broad global answer and highlight, here's a process for considering potentially, problematic or confounding factors that would limit the success of reforestation opportunities in those places. Not at all to say that reforestation opportunities don't exist in places with fire or savannas.
Yeah, I think it it's a flag that extra care is needed to make sure you're restoring an appropriate density and fire adapted species, and which I'm sure people on this crowd are doing. So we're not trying to say you should do this here and not there, but like here are definitely like good places for climate, and here are places where you gotta be extra careful.
One more question for me, and if folks have more, please feel free to send them in the chat. But as I think we're thinking about the ramp up to COP30 in Belém, which is, you know, colloquially going to be termed the forest COP, right? The first COP in the Amazon. The Brazilian government is making a concerted push to put a focus on avoiding deforestation and reforestation. What would you tell the policymakers who are gathering in Belém this November, and how would you want them to take your data and improve or make policy choices or do more for forests around the world?
I mean, what I would say is, I mean, it's like 100 degrees here in DC at the moment, and my kids are outside at summer camp, and like, I'm concerned about their health, right? Like, climate change is here and now, and we don't have time to spend on sort of like vague, poorly defined ambitions. We really need to start acting and getting trees moving in the ground now. Reforestation remains a powerful climate solution. It's one of the most cost-effective carbon removal solutions we have now. And we hope our work helps to shine light, as I said, on the places with the greatest potential, so we can spend less time spinning our wheel trying to figure out what to do and more quickly focus and sort of leap to action, because we have lots of great ambitions for reforestation. Everyone loves planting trees, regrowing trees. I'm one of them. But we need to actually get actually going on.
Perfect call to action, I think, to end things off, and appreciate the perspective and really appreciate both of your work and your time in sharing this really exciting new research. And yeah, I truly hope that this can help provide some really important directionality to the global conversation. Not spin our wheels, but to start getting work done on the ground. So really appreciate that. We're looking forward to having some additional conversations this summer with the 1T.org US community. July 31st, we'll be joined by our friends at the Conservation Labs and their really exciting new challenge, Grand Fire Challenge, that's putting a spotlight on some really cool innovators in the fire space. And especially with regard to the forest community. Then we're going to be joined by some other colleagues from the U.S. Nature for Climate and some state level leaders who are doing some really exciting work around reforestation and afforestation and forest conservation and in California, Minnesota, and Georgia. So excited to have both this really cool tool, another decision support tool for policymakers, and also some fun examples from the ground of what success is looking like in these nature-based solution space. And then finally, our friends at the Arbor Day Foundation have conducted a poll of 2,000 adults in the United States. They call it their Canopy Report, How America Sees Trees. And it's going to be a very cool conversation about how our fellow citizens and residents are looking and think about trees through a number of different lenses. So excited for those conversations, and really grateful, Susan and Kurt, for your time for the science, and look forward to having you both back in the future to continue to educate and elucidate and highlight opportunities for our community. So thank you all for being with us. You'll expect an email next week with some follow-up with some links. And thanks again, and happy 4th to everyone, and have a safe and hopefully forest-filled 4th of July. Thanks all. Be well.